This episode of Inspire AI podcast is sponsored by Exponent 21. I keep hearing the same thing from business leaders lately. We're doing the work, but leads are harder to explain. Traffic is down, attribution feels fuzzy, and the old answers don't really fit anymore. What's changed is how people search. Instead of clicking links, people are asking questions, and AI is answering them. Tools like ChatGPT, Google's AI-powered results, and Perplexity are shaping which brands get mentioned, referenced, and remembered. Exponent 21 specializes in AI SEO. They help businesses understand how to show up consistently inside those AI-generated answers across questions about their industry, their services, and their brand. What stands out to me is that when people ask AI tools, who's leading in this space? Exponent 21 and its leaders are often referenced near the top. That comes from doing the work and shaping how this new search environment actually functions. To understand what this shift means for your business, visit exponent21.com. Welcome back to Inspire AI, the podcast where we explore how leaders, builders, and communities can stay thoughtful, adaptive, and prepared in an AI-accelerated world. For decades, software engineering followed a fairly predictable pattern. Humans translated ideas into manual code, you learned programming languages, you memorized syntax, you debugged systems line by line, you had to look things up on Google, etc., etc. So many years were spent building expertise around implementation. And for a long time, the ability to write code efficiently was one of the most valuable technical skills in the modern economy. But as all things do, something fundamental changed. Because for the first time in the history of software development, the actual act of writing code is no longer the primary bottleneck. As we know, AI systems can now generate applications, scaffold infrastructure, write tests, refactor systems, debug the errors, and increasingly coordinate entire workflows. And while many people see this as a story about automation, it's actually a story about abstraction. That's what we're exploring today. Not the end of software engineering side of things, but the end of coding as we've traditionally understood it. Because one of the most important patterns in the history of technology is this: every major leap in computing abstracts away complexity. At one point, programmers worked directly with machine code. Then higher-level programming languages emerged. Frameworks simplified development, cloud platforms abstracted infrastructure, CI/CD automated deployment, APIs compressed complexity into reusable systems. And every time abstraction increased, something interesting happens. Humans stop spending time on lower-level implementation and start operating at higher levels of leverage. This is the broader arc of computing history. The history of software is in many ways the history of removing friction, and the AI is simply the next major abstraction layer. But this layer is different, because unlike previous tools, AI does not just automate execution. It participates in generation itself, and that is a profound shift. For years, engineering organizations scaled largely through human implementation capacity. Need more software? Hire more engineers. Need more features? Expand development teams. But AI changes the economics of production dramatically. Today, developers can increasingly generate boilerplate systems, interfaces, back-end services, infrastructure configurations, documentation, and test suites in minutes instead of days. And this changes the nature of engineering work, not because software stops mattering, but because implementation becomes increasingly compressible. The value begins moving elsewhere, and I think this is where many conversations become confused. People often frame this as AI replacing engineers, but historically, abstraction shifts rarely eliminate technical roles entirely. They reposition human value upward. When cloud computing emerged, infrastructure management changed. When frameworks emerged, front-end workflows changed. When automation expanded, deployment changed. And now AI changes implementation itself. So the role must evolve. I think one of the biggest mistakes organizations can make right now is assuming the future bottleneck is still code production, because increasingly it's not. Once generation becomes easy, other constraints become more important. You'll start asking questions like, what should we build? What problem actually matters? How do systems interact? How do we evaluate outputs? How do we maintain trust? And how do we coordinate complexity? And of course, how do we govern these intelligent systems responsibly? These become the harder problems, and more importantly, they're judgment problems. This is why I believe the software engineering is moving up the abstraction stack. The future engineer will spend less time manually writing implementation details. That is a fact. They will be spending more time designing systems, orchestrating workflows, evaluating outputs, defining constraints, aligning organizations, and managing the trust while coordinating these intelligent systems. If you're a software engineer, you should prepare for a very different professional identity. Part of the reason this moment feels emotionally intense is because coding has been long treated as the core identity of engineering. To many people, writing code is engineering. So when AI begins generating code effectively, it feels existential. But if you zoom out historically, the deeper pattern becomes clear. Technology repeatedly automates lower-level implementation while increasing higher-level leverage. Engineers once manually managed memory. Then, operating systems abstracted much of that complexity. Developers once manually configured infrastructure. Then, cloud platforms compressed those workflows. This pattern repeats continuously, and usually the people who thrive are not the people who cling to previous abstraction layers. They're the ones who evolve upward with the technology. The future engineer actually might look like more systems-oriented, more disciplinary, more strategic, more evaluation, more communicative. They still need to be tech literate, of course, but understanding systems deeply remains more important at this point. Because as I said, value shifts toward the architecture. And I've spoken about orchestration and product thinking, even systems leadership. I'm going to get into more of those things as episodes go on here in this series, but bottom line, the engineer becomes less like a manual builder and more like a conductor of intelligent systems. So again, it's just another transition. It's a shift that extends far beyond software development, though. Software increasingly shapes business operations, from healthcare, education, logistics, finance, government, and communication, all of it. And when software creation accelerates dramatically, organizational change accelerates too. There'll be way more experimentation, way more automation, far more complexity, and the decision velocity increases exponentially. That means leadership must evolve. Organizations will increasingly need people who can guide intelligent systems, evaluate rapidly, coordinate humans and AI workflows, preserve trust under acceleration, and, of course, align technology with mission and values. That's the strategic part. What I get the sense of is that it's a societal adaptation challenge, not just a technical one. I think this moment forces us to rethink what human value actually means in knowledge work. Most, if not all, of us listening to this podcast are knowledge workers. So for a long time, technical scarcity created economic value. But because AI is changing the scarcity dynamics and implementation is becoming abundant, human value migrates upward into the judgment spaces and the coordination and creativity, systems thinking, and strategic clarity. This is a redistribution of human leverage. Think about that. One of the biggest misconceptions of AI that I read all the time is the assumption that it primarily threatens engineering. I read about it, I hear about it, I feel it. In many ways, it may actually expand engineering, because it certainly expands what we can build. It scales experimentation. It expands our organizational capability and our individual leverage. Of course, it can generate enormous amounts of software rapidly. So now's the time to define your direction. Be an evaluator of the outcomes. Don't just accept them. Coordinate the complexity and preserve your own trust and the system's trust. If you're an engineer or a leader or anyone else, that's the new challenge. Because those who thrive in the next era won't be the fastest typers. They'll be the clearest thinkers, the best system designers, the strongest evaluators, the most adaptable leaders. And that's it. So until next time, stay curious, keep innovating, and keep building the kind of judgment that grows more valuable as intelligence becomes abundant.